Right. I think we are supposed to discuss the paper today. Have you all tried the paper?
Yes, sir.
Yeah. Are there any doubts?
Yes, sir.
So go ahead. Which one?
One second. I'm telling. Sir, can you go to option? Sorry, question number 6.
Yes.
Sir,
ABCR,
so yeah, you read the question.
ABCR square matrices of the same order. Which of the following is true?
Yeah, sir. So, sir, can you explain the option D?
What is the answer? D.
Sir, answer is D.
D in Delhi.
Delhi.
Why is it D?
सर क्या बोल रहे हैं?
Why is it D?
Sir, the solution, they said that same order is true because theory, but we have if AB is an identity matrix, then BA must be an identity matrix. So AB is equal to I, so AB is equal to BA.
Okay, we'll come to that. Anyway, option A is saying AB equal to AC, which makes no sense because you don't know what is A, what is B, what is C. So this cannot always be true. Okay, right?
Yes, yes, sir. Yes.
Now the second option is telling AB whole square. What is AB whole square? And is it equal to A square B square? Let us verify. We already learned that AB, let us say AB is another matrix C. So in other words, this is C square. But in matrices, what does C square mean? C square means C into C. This we have learned. So in this case, if C is AB, this is AB times of AB. And because matrix multiplication is associative, maybe you can write AB into BA into B, something of that sort. But is this necessarily equal to A square B square? No. Why? Because A square B square is A into A into B into B. These two are different, na? है ना? AB is not equal to BA.
Yes.
We cannot say both of them are same. Okay. Option C we have discussed in the class elaborately. AB equal to 0 does not necessarily mean either A is 0 or B is 0. And we have given examples also. Okay. Is that okay?
Yes, sir.
Yeah. Option D is what I'm thinking about. It is given that A into B is equal to I. So then can we say B into A is also equal to I? What is the option? One second. Implies A into B equal to B into A. Yeah, this is interesting. So how does this work? Anyone has a good idea? A into B whole transpose should be equal to A into B. This is also there. B transpose into A transpose. It doesn't seem useful. If AB equal to I, can we say AB equal to PA? Okay, let us multiply both sides with A. Maybe AB into A will be I into A into B. But A is same as A into I. But again the same problem, no? This does not necessarily mean BA is equal to A into BA is equal to A. One second. Okay. We can write this as BA minus I is equal to 0. Right? But
और आप ए बी मतलब आई ए को ए नहीं लिख सकते तो बाद आई मीन यू कैनॉट कैंसिल ए राइट इफ दे आर इन द इक्वेशन
why now you're telling cancel what you're telling cancel until BA is equal to I.
अच्छा हाँ वही वही वही
That is not always allowed. That is the thing. If AB is null matrix, right? Anyone else has any idea? No. I have one small idea. You see, if the product of these two is a null matrix, surely we can tell that the determinant of A is not 0. Taking determinant on both sides, we know that this is not 0 from this equation, because from this we can tell det A into det B is equal to 1. So neither of them can be null matrix. But then this is equal to 0. That means the determinant of BA minus I is a determinant of BA minus I is 0. ठीक है. Oh, अच्छा. What is the solution there? I think solutions are there. What is the solution of this?
The solution में बोला है कि if AB is an identity matrix then BA is also an identity.
एक लाइन में. Question number 6. ABC are square root of the same order, then ABI implies AB is true because by theory part we see that if AB is identity then BA must be identity. I don't know. I'll have to check. I'm not convinced. Okay. I cannot teach something I'm not convinced. If someone is convinced, you can convince me. At least I'm not convinced. Chale, let's move on. So if I were in the exam, I'd mark D. Not because I know it's right, but because I know ABC are wrong. Okay. Fine.
Okay, sir.
Next.
Question number 12.
Symmetric मतलब ये दोनों equal होगा. X plus 3 will be equal to 2x plus 1. So x plus 1 will be 3. So
Sir, the symmetric matrix के definition में तो आपका वो रहता है ना, मतलब
ये दोनों equal बस और क्या. Aij equal to Aj.
Sir, diagonals are equal, right?
Diagonal, no, that is not necessary. Diagonal is irrelevant.
No, I mean, sorry. If A is equal to A to the power, I mean A transpose. A is equal to A transpose.
So diagonals anyway don't change. Na transpose में diagonals don't change anyway. Diagonal elements remain as they are. है ना?
Can you tell again?
Okay. What is the transpose of this? इसका transpose क्या होगा?
The x plus 3 will be 2x plus 1 and then x plus 3.
Yeah. So what is happening to the diagonal elements? What are the changes that are taking place in the diagonal elements? Huh?
Diagonals are getting interchanged.
Diagonal elements. What are the diagonal elements?
At the diagonal elements.
They are remaining same.
Remaining. No change, na? Transpose करने से diagonal elements don't get affected. Okay. Fine, Mayuk.
सर वो सिमेट्रिक मैट्रिक्स के डेफिनेशन में ही है तो
क्या है? Aij equal to Aj, Ji.
One second.
It is
But वो तो sir diagonal elements are not change. That is this diagonal. मतलब 1 or x minus a. This will remain same.
Remain same. Yeah, whatever they are, they will be the same thing.
But how are you telling the 2x plus 1 is equal to x plus 3?
अरे ये दोनों equal होना चाहिए ना? How can you tell these two matrices are same? When do you say two matrices are equal? If all corresponding elements are equal, na?
Oh yeah.
So
Sorry.
this will be
Yes
equal
sir.
to transpose. Now,
Yes sir.
So if A is equal to its transpose, then we have to equate corresponding elements. ठीक है?
Okay sir. Okay yeah.
So at least in my notes, I did not talk anything about diagonal elements. शायद दूसरा ट्यूशन में कुछ बोला. Any other doubt?
Sir, question number 17. 15.
1-5. Assuming that the sum and product given below are defined, which of the following is not true for matrix? Which of the following is not true? That day.
So this question and the sixth question, like from there you can get the answer for this question.
From where you can get the solution?
Yeah, from the sixth question you can get the answer for this.
Okay, let's see. So, but before that, the other day, those of you who attended the seminar afternoon, you should be very careful with these questions. Or Lakshminarayan, alumni USC. Not as soon as you not, it is according to statistics, more than half of the students make mistake in this question. Not. So be careful about not. Not means you should identify the incorrect option. So that means 3 options are correct. So you should go ahead and see which all options are correct. Don't mark anything. Just mark correct wrong options first. AB equal to AC does not apply. B equal to C. True. AB A plus B equal to true. AB transpose equal to B transpose, very true. So definitely this must be false. Now not true is this. Yeah. What is the doubt in this, Mayuk? This has nothing to do with sixth question anyway. The few options are same, but
So the last option, it's incorrect in that question. So you actually don't need to check all the 3.
that is it. Anyway, what is your doubt, Mayuk?
सर इसका सॉल्यूशन में देखिए, इसका सॉल्यूशन में the answer is given option A, and they are saying that AB is equal to AC implies B is equal to C by right cancellation law.
AB equal to AC does not imply B equal to C. Is not a true statement because AB and AC implies B equal to C by right cancellation law. This is not right. See, the answer is D.
क्या बोल रहे हैं?
Answer should be D only.
So
Okay.
what is right cancellation law?
Right cancellation means you cancel the matrices on the right side. In matrices, it matters now who's on right, who's on left. If xy equal to 2x, you can just cancel xx. But in matrices, it doesn't work like that. Matrices is if AB is equal to AC, and if these two are on the right side, you cannot always cancel out these two. But when you cancel out, you say it's a right cancellation.
Okay.
And it's not always possible. Okay.
Sir, under which circumstance can we cancel it?
One second. AB equal to AC. When can we cancel it?
Sir, a question.
Wait. We can cancel it when it is a non-singular matrix. Okay.
Non-singular matrix का मतलब एक बार बोलेंगे?
Determinant not equal to 0. Okay.
Okay.
But if it is a singular matrix, you cannot cancel. Fine.
Okay, sir.
Don't you want to ask why? That someone will ask why. Okay, fine. Yeah, Vinky, what you're asking?
सर अगर इसमें दिया होता कि B और C is already equals to B is equals to C, तब क्या ये मतलब ट्रू नहीं होता?
अगर इसमें दिया हुआ कि B is already equal to C, then what is your question? समझा नहीं.
मतलब अगर B equals to C, then AB equals to AC नहीं हो सकता?
हो सकता है. Why not? If B equal to C, then AB is equal to AC. True. But that product should be what do you say? Conformable. That such product should be conformable. It should be allowed basically. Order वो सब allowed होना चाहिए.
Sir,
Yes.
so can you show the proof for that singular thing?
Good. Thank you. See why I said this. If the determinant is not equal to 0, then you can define A inverse. Okay. And if you can define A inverse, then when you say AB is equal to AC, now because the inverse is defined, you can multiply the inverse on right side. That is actually right cancellation law. You multiply A inverse on the right side on both sides. Okay. And now because the product is associative, this becomes I and this also becomes I. And now it implies B equal to C. But in case where this is not mentioned, you cannot directly say this. Okay. Fine.
Yes, sir. Yes, sir.
Sir, A times A inverse. Sir.
I होते हैं.
Okay, sir.
A into A inverse equal to A inverse into A equal to I.
मतलब अगर हम इसका A का अगर इनवर्स अगर इसका प्रूफ हो सके तभी B इक्वल्स टू C हो.
Yes. हाँ हाँ क्या क्या क्या.
अगर A का इनवर्स हो सके तभी मतलब B इक्वल्स टू C हो.
Yeah. Now I think it strike to me. Now I can make sense of the first question. Not first. Sixth. Yes. Now I can tell the sixth one. See, this is how sixth one goes. But see, even in sixth, they have to give more data. They have to mention that if it is mentioned that they are a non-singular matrix. Yeah, it is non-singular. Fine. See, now I'll prove the sixth one. Sixth one, option D. Yeah, I got stuck there. See, A into B is equal to I, right? Now take a determinant on both sides. So mod A into mod B. So you multiply two numbers, you are getting one. So definitely none of them is zero. Clear? Hence A is non-singular. This is okay?
एक second. If you are taking the determinants one. हाँ सर ये वाला फिर से बोलिए. Therefore A is non-singular.
मतलब determinant A is not zero.
Okay. Yeah.
Okay. Now because determinant A is not zero, now multiply with A inverse on both sides, which implies A inverse into A into B is equal to A inverse. Okay. This is okay. I'll change color. This is the important step. And after that, you can tell A inverse into A is I. So I into B is equal to A inverse, which implies B is actually the inverse matrix of A. Yeah. If B is the inverse matrix of A, hence we can tell B into A is also I. Yeah, this is a perfect proof. Actually, this is the definition of inverse of a matrix. We learned today. Okay. Forget all.
Wait a second.
Anyway, I did not teach this last week. Neither I taught it now. I'll teach it today's class. Because this has to be taught after adjoint of a matrix. Right. Oishi was asking fifth question.
Sir, question number 17.
Yes, sir.
17.
Yes, sir.
This I told that day before the exam. Did I tell you guys how to do this before the exam? If f of x is this polynomial, then you can define f of a as a matrix polynomial a square plus 4a minus 5i.
Why does I comes?
Huh?
सर ये तो ठीक है कि आप you inserted a in place of x, but why does this I comes? 5i.
Sir, I have an answer for this question.
Yes, please.
Sir, because you cannot add or subtract or do any operation with an integer and a matrix. So to convert the integer to a matrix, we multiplied by I, because I is like 1 into like 1, 1, 1. So it does not actually change the value.
Okay. Actually, this is what I told in the last class. When I explained this, I told the same thing. We multiply this because you might think why we are not writing this. As she said, we cannot have an operation between a vector and a number, or matrix and a number. So therefore, to convert into a matrix which is not going to affect the equation, we multiply I. It's defined like that. Okay.
Okay, sir.
Okay, fine. If I get some better explanation, I'll tell you. As of now, that's it. And Oishi, you are asking?
Sir, the fifth question.
I00I. I think your friends must have done this. Koi kiya fifth? Can you write this as A equal to? Can I take I common and say this is I times of I?
Yes, sir.
So if you raise 4 to the power n, what happens?
अरे इसका आंसर ए आ रहा है पर आंसर सी दिया हुआ है.
हाँ sir.
Is it?
Yes, sir.
Oh. Solution क्या है? A square is equal to minus I. See, even if A square is minus I, then A square into A square will be plus I. है ना?
Yes, sir.
Yes, sir.
सर यह आई स्क्वायर मतलब कैसे -1 हो जा रहा है इधर?
I is iota.
कॉम्प्लेक्स नंबर्स याद है ना विष्णु?
सर याद तो है लेकिन समझा नहीं कि वो आयोटा है कि
I root -1 होते हैं ना? अच्छा, you didn't understand that this and this are same
no,
thing.
I think that it's very
ठीक. The answer should be A. ठीक है? That was your doubt, Oishi.
Yes, sir.
Yeah, answer should be A. Next.
So can you tell the first question?
Three by one. 1 by 3. 3 by 1.
So then how are we supposed to get the answer in the option?
Sir, ये तो none of these होगा.
हाँ sir.
Answer वही है क्या?
Yes, sir. It is none of this.
Okay, sir, I did not check the solution.
Okay. Thank you. Next.
The question number 21.
A inverse तो सिखाया नहीं ना अभी. First
Sir,
I
actually, in one page you told us that you had a doubt in that. You told when you were teaching orthogonal matrix, you proved that A transpose is equal to A inverse.
if it is orthogonal. If it is orthogonal. Not always. Okay.
So, अच्छा ठीक है. So today you will discuss the A inverse.
Yeah, if time permits.
Then
After that, you'll be able to do this simply.
sir, then question number 24.
This satisfies the equation. Same thing here. This becomes A square plus Ki equal to 0. ठीक है? So what is A square? ABCD into ABCD. Row, column. What will the product be?
Product I have done. So product होगा A square plus BC the R1 C1 it will be A square plus BC. उसके बाद to the right of that R1 C2 will be AB plus BD. Okay, yeah, and AC plus BC, then BC plus D square.
Okay, is this useful? I don't know if it's useful. Acha, but one thing is useful. On adding both, you are getting null matrix. This will become null matrix when you convert to matrix. So only one thing what I'm focusing. Okay, I'll do it. Okay. X square plus k. Yeah, A, B, C, D. A, B, C, D satisfies x square plus k. So if this is f of x, if f of x is equal to x square plus k, then f of a is equal to a square plus k times of I, and this should be equal to null matrix 0. Okay. What are the options? A plus d0, k minus jd, k equal to dt. None of this.
ऑप्शन ए आ गया उसके बाद.
ऑप्शन ए आंसर आ गया क्या?
Yes sir.
तो डाउट क्या है फिर?
Sir, the determinant part.
Why bother it if it is not answer? Then why? What you want me to do? आंसर आ गए ना ये.
सर ये आप बोलने के बाद ये आया.
Then what you want to tell me?
Sir,
What
it
you
is
want-
multiple correct.
Huh?
It's multiple correct.
अच्छा. Oh. चलो. At least answer is not 4. If it is 1, it cannot be 4. And on multiplying this, a square plus BC, this becomes a b times of a plus b. This becomes c times of a plus b. This becomes okay. K 0 0. And in the question it is told b into c does not equal to 0. Very interesting. B into c does not equal to 0 means neither b is 0 nor c is 0. That means in this equation if b is not 0, then necessarily a plus d is equal to 0. Okay. So then this matrix will look like this: a square plus bc 0 0 same a square plus bc is equal to k. Actually, if you take determinant on both sides, what will you get? You'll get determinant of a square is equal to k square. Isn't this true? right? And a square plus bc should be k. So what is the answer? ABC? Huh? Oh, we made a mistake here. If this is a square plus ki equal to 0, then this is minus k na here. है ना? It's written in the solution. So minus k is equal to a square plus bc.
एक मिनट वो
Hmm?
नहीं 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 कुछ नहीं
Yeah. So anyway, this is the answer. They're getting both the options. You understand what they're doing? It doesn't seem like a very fantastic question to me. They're writing a square as a into minus b minus ad plus bc equal to minus k. This is the step. And from here they're telling k equal to ad minus bc. Okay. Which is equal to delta. This is one step in the solution. Also,
सर वो mod sorry you lifted the square signs so minus क्यों नहीं होगा
होगा ना? What is the answer? I thought answer was plus minus. Only plus?
Sir, answer is only plus.
yes sir answer is only plus
One second, actually. The mistake I made here is it should be minus k. That is the mistake I made first of all. But then if I take mod on both sides, determinant of a square will be equal to minus k minus k. Determinant of a square is equal to minus k. है ना? No. This is wrong. Minus k square. Do you understand why it is minus k square anyway?
yes sir
Okay. From his solution, I understand, but on my own, I'm not able to. Determinant of a square will be k square, k equal to plus minus. Okay, let us put it this way. If k is equal to determinant of a, did you understand what he did? You understood what he did at least. After getting this a square plus b is equal to minus k, he is writing one a as minus b plus bc is equal to minus k. And from there is saying k is equal to ad minus bc, which is delta. That is what he got. This is a solution, but
Sir,
huh.
so why are you writing minus d? It can also be plus d.
Why am I writing minus d? How it can be plus d? We got a plus d is 0 no? Here. If a plus d is 0, a will equal to minus d.
Okay, okay.
So his way of doing it, he got this, but I am trying something else, by which I am not getting much. Okay, let's put it this way. What is determinant of A? Determinant of A is AD minus BC. Okay, which implies minus A square minus BC is equal to whole square. Whole square is equal to K square.
The determinant of a square plus मतलब a square plus bc into a square plus bc minus 0 होगा.
Yeah, वैसे भी कर सकते हैं. A square plus BC whole square बोल रहे हैं ना?
Yes, yes, yes.
वो बड़ा लग रहा था इसलिए ऐसे नहीं किया.
पर वैसे करने से तो mod of a is equal to determinant of a is equal to k square आ जाएगा.
Determinant of A equal to K square.
Yes, sir.
Okay, wait, let me finish what I'm doing. See, minus A square minus BC whole square is equal to K. From here, we can tell minus A square minus BC is equal to plus K, or minus A square minus BC is equal to minus K. Ah, yes. But K cannot be positive. Something like that. See, if x square plus K is equal to 0, then if we assume K is negative, I don't know, I'm not very clear actually. I'm very clear with his solution. He simply wrote this. He simply equated this coefficient. Minus AD plus BC equal to minus K, and there he got K equal to determinant. Finish. I'm trying an alternate way, but not getting it. Okay. We'll come back later. Maybe something will hit later. Anyone has some solution, you can tell.
Sir, AD minus BC वो determinant है.
हाँ, एक determinant y and AD minus BC.
Sir, how is it the determinant?
Definition है determinant क्या होगा? AD minus BC होगा.
अच्छा, sorry. अच्छा ये आएगा. Yes, sir.
चलिए, fine. So from what he did, we understand K equal to delta, and we know A plus D is 0.
Yeah.
Fine. I'm going ahead. I'm not spending more time. Fine. Okay.
Yes, sir.
This is the solution. Any other questions? No? That's it. Okay.
Sir,
Huh.
for the 28th question, I didn't understand the solution.
8. Question
28.
8. 8.
Sir, 28.
Matrix of order 2 by 2 commutes with every matrix of order 2 by 2. Then it is scalar. If it commutes with every other matrix of order 2, then it is scalar. Statement 2. A scalar matrix of order 2 by 2 commutes with every 2 by 2 matrix.
Sir,
Huh.
sir, if it has to commute with every matrix, then it has to be an identity matrix.
Scalar matrix. Scalar matrix is
Yeah.
also identity.
Yeah. So in that way, can we give the answer?
Yeah. Yeah, seems fine. But then he's telling answer is D. It is not correct explanation. Both are correct and it is not correct explanation. If a matrix of order 2 by 2 commutes with every other matrix of order 2 by 2, then it is scalar. Scalar matrix of order 2 by 2 commutes with.
Sir, I took two matrices and I convinced myself sort of. If I take I, then only that matrix commutes with every other matrix. But if I take any two other scalar matrices, they don't commute.
Any two other scalar matrix?
Yeah, any
No,
two
no.
scalar matrices.
No, every two scalar matrix will commute. That is the second statement. Na? A scalar
Yeah.
matrix will commute. See, scalar matrix is some k times of I. So what is the problem? Scalar matrix is k times I. Na? So whatever is true for I will be true for k times I. Okay. Okay. So the solution, he took two arbitrary matrices and he's multiplying it. And after that he's comparing on both sides, equating them because they commute. AX got cancelled, so that's why BZ is equal to CY. BZ equal to CY is writing like this. Then that means he's saying they are proportional, right? Did you understand till here, Oishi?
Yes, sir.
Okay. After that, he's telling let that be equal to lambda. So y equal to b times lambda, z equal to c times lambda. Next, he is comparing. He's comparing ay plus b. What? So he's comparing this one, this. Okay. But y is b lambda, b dy. अच्छा. So directly यहाँ actually ये dy. Somehow you missed out. Okay. So ay plus bu equal to bx plus dy. Ay plus b equal to bx plus dy. Clear?
Sir,
हाँ.
sir, that y they are writing is b lambda from the.
Yes. Yes, that y we are writing as b lambda. And then you're cancelling b on both sides. Then you get this.
Okay.
And again, he's assuming that as some k.
Okay, sir.
Wait. After that, what is it doing? A lambda plus u equal to x plus b lambda. For lambda equal to 0, u will be equal to x. And u will be equal to x equal to k. Okay, this is fine. And if lambda is 0, then yes, z and y will be 0. Yes, this is fine. Acha. For lambda equal to 0. See, basically when lambda will be 0, what is happening? Z and y are becoming 0. When you're saying lambda is 0, you're basically making matrix B as a scalar matrix because x is becoming equal to u and y and z are becoming 0. Both a and b are becoming scalar matrices for lambda equal to 0. Okay, so for lambda equal to 0, b is a scalar matrix, and also a is also a scalar matrix. Then ab equal to ba equal to k. What is he trying to say?
Sir, how A is scalar?
Lambda equal to 0. If lambda equal to 0, then z and y will be 0, na? Huh?
Yes, sir.
1 second. Z and y will be 0 and u and x will become k. Okay. This is a scalar. Okay. Yeah. A is not a scalar as of now. B becomes a scalar. Okay. B is a scalar. यहाँ तक ठीक है. So after that is multiplying A into B and that becomes equal to B into A. That is k times A. I understand everything till here. I think you also understand.
Yes,
Then solution ends. So what did he prove by all this? Forgot the question. Matrix is 2 by 2 commutes with, then it is scalar. If a matrix commutes with every other matrix, then it is scalar. Okay. Did anyone get anything? Actually, I understood and all this. I understand that B becomes a scalar matrix, and after that, I understand that AB equal to BA will be equal to K. But how that helps in the question? Is anyone able to catch? If a matrix of order 2 by 2 commutes with every matrix of order 2. So maybe he's saying the matrix B commutes with every other matrix and A is any arbitrary matrix. So therefore he proved that B is a scalar matrix. That would support first statement. And a scalar matrix of order 2 by 2 commutes with. Scalar matrix commutes. Statement 2, there is no problem on it. Okay. See, I think the solution is like this. He has assumed that he is taking a matrix B and is assuming that it commutes with any other scalar matrix, sorry, any other matrix of order 2. Therefore, he is writing B equal to AB. And from here is proving B is scalar. This, I think, is taking as an arbitrary matrix.
सर लेकिन वो जो ए है मतलब ए तो आपका इधर स्केलर कैसे हो रहा है मतलब उसका तो बाकी एलिमेंट 0 और डायगोनल 1 तो नहीं है
ए स्केलर बोला नहीं, आई एम नॉट सेइंग ए स्केलर, ठीक है? We are saying A is some arbitrary matrix, and if B is being if B is commuting with any arbitrary matrix A, then is proving that B is scalar.
Whether it is possible that if A is not scalar, B is not scalar, but AB is scalar.
A is not scalar, B is not scalar, but AB is scalar. Is it possible if A is not scalar, B is not scalar, A into B is scalar?
Sir, can we take trigonometric matrices?
No, wait a second. 1 second. Yeah, it is possible because that is what we saw in orthogonal matrix. In orthogonal matrix, the matrices we deal are not scalar, na? But still A is not scalar, and we see because A is not scalar, A transpose is also not scalar. But A into A transpose is I, which is scalar. So it is possible. Okay.
Okay, sir.
Can we take trigonometric matrix? Depends on how you are taking, what you are taking. If the trigonometric matrix is a orthogonal matrix, then again it is true. Okay. Fine. Okay. I think we should end. Discussion is becoming more arbitrary. ठीक है ना? So I am trying my best to justify what this fellow did. ठीक है? Oishi only asked. You're fine.
Yes, sir.
Yeah.
सर यहाँ क्वेश्चन में मतलब लास्ट में जो स्टेटमेंट 2 है उसमें बोला गया कि स्केलर मैट्रिक्स ऑफ ऑर्डर 2 by 2 कम्यूट्स विद एवरी 2 by 2 मैट्रिसेस, तो ये तो आपका स्केलर नहीं है, तो लास्ट में तो वही प्रूफ हो रहा है सॉल्यूशन में भी.
नहीं. Statement 2 is telling if a matrix is scalar then it commutes, which is always true.
हाँ,
हम
तो
क्लास
B
में भी बोला
स्केलर
है,
है.
या हम ये प्रॉपर्टी क्लास में एक्सप्लेन किया था. This is always true. So scalar matrix क्या? Scalar matrix हम ki, so it is still true. This is what is telling in second statement. This is always true. First statement is something different. Third statement is telling if a matrix of order 2 by 2 commutes, it's actually the it's like ulta statement, you know. This is telling a scalar matrix will commute. First one is telling if it commutes then it is scalar. So the converse statement is always not necessarily true, na? See, A implies B does not always mean B also implies A, है ना?
Yeah.
So this one is fine. That if it is a scalar, then yes, it what do you say? Then it will commute. But if a matrix commute, is it scalar? That we checked, and we saw that if a matrix is commuting with every other matrix, then that matrix has to be scalar matrix. Okay, this fellow proved it systematically by doing all that. ठीक है, हमें हाँ.
Sir, then why aren't we saying that the option A is correct answer?
It's correct only, no? Why it is not correct? See, what I said in the last statement, I told A implies B does not always imply B equal to A. B implies A. Now you see, this is not exactly the same statement. See, if this statement would have been, if two matrices are commuting, that means one of them is scalar. Is this true? If two matrices are commuting, is it necessary that one of them is scalar?
No, sir.
No, that's what. But if exists a matrix which is commuting with every other matrix, then is that scalar? That is statement one.
Okay, sir.
And that he has proved systematically doing all that stuff. Okay.
Yes.
Okay. Anything else? और किसी को कुछ डाउट है?
सर आप थोड़ा वो मतलब स्टेटमेंट 1 फिर से समझा सकते हैं मतलब सॉल्यूशन में.
Okay, I'll tell you how to understand. You take time and understand later. ठीक है ना? You consider a matrix B, okay, and say that it is commuting with any arbitrary matrix A. This is, you take this as any arbitrary matrix. मतलब A B C D कुछ भी हो सकता है. कुछ भी मतलब कुछ भी हो सकता है. ठीक है? If you say that matrix B is commuting with every matrix A, that implies AB will be equal to BA. After that, you do all this procedure, and you're getting B is a scalar matrix. This is what he is trying to prove. Bas. Okay. Okay. Chalo, we'll move ahead with this. What did we discuss in last class?
Sir, we discussed till point of destruction. Point of definition and point of destruction.
What is point of destruction? That determinant. Yes. That I made up, है ना? It's not a textbook thing.
Achha.
So today we'll go to the next one. Okay. Right. The adjoint of a matrix. The adjoint of a matrix is defined. The adjoint of a matrix is defined as the purposely I'll use a different color so that you don't forget. As the transpose of the cofactor matrix. Luckily, we discussed all this in the last class. Okay, the adjoint of a matrix is defined as a transpose of the cofactor matrix. Right. What do you mean by cofactor matrix? A matrix where every element is representing the cofactor of the previous matrix. I'll give an example. If A is equal to 1, 2, 3, 4, then if B is equal to cofactor of A11, or in short C11, C12, C21, C22, then I can tell B is the cofactor matrix of A, and this implies B transpose is the adjoint of A. This is the symbol of adjoint. Okay. In this case, B will be equal to, what is the cofactor of 1? Remember cofactor?
4.
Here?
3. Minus 3. Sorry.
Minus 3. Which implies adjoint of A will be equal to, what will the adjoint be? 4 minus 2 minus 3. Okay. Is that okay? Everyone understood the definition of adjoint of A?
Yes, sir.
Observe. Let us make some observations. We observe that data is equal to minus 2. This is the first observation. Okay. Second observation. We observe that 1 by det A into adjoint of A. What is 1 by det A into adjoint of A? Huh? बोलिए जल्दी बोलिए. Minus half. Is that okay? Is equal to some B. Let us say some this is some B. Observation 3. A into B. Can all of you check what is A into B? 1, 2, 3, 4. What is this turning out to be? Matrix multiplication आता है ना सबको. Giving hint.
It's an identity matrix.
Really? Identity matrix means which matrix? What did the others get?
Yes, sir. It is an identity matrix.
You
Coming
mean,
an identity multiply करने के बाद.
are you saying this is what you got?
Yes, sir.
Why you got this?
Yes, sir. My it's all it's identity matrix.
Havingshu also.
Yes, sir.
How is this possible? What is happening here?
Sir, you gave a random example.
We were just playing around, we were fooling around, and we just tried to multiply, and out of nowhere, how did identity matrix come? What is happening?
So this 1 by det A B, is it equal to B or something?
1 by data, is it B? No, we are naming it as B.
No, not this B. I mean the one which you have given in the upper part. Like B is equal to 4 minus 3 minus 2, 1.
Oh, no, sorry. Okay.
Sir, A is equals to E transpose.
No, A is not B transpose. How A is B transpose?
No, no, no.
Sir, I asked
Wait, who's
because,
that hissing? Someone is making snake sound. Yes.
sir, because B transpose into B is equal to I, identity matrix.
But who told so? That when does that happen?
When A is an orthogonal.
Orthogonal. Did I say it is orthogonal? Is this looking like an orthogonal matrix?
Mhm.
How is this happening? What is this magic? Okay. By mistake, we just stumbled upon this result, I guess. And let us all forget this and move ahead.
Yes, sir, you gave a random example.
Yeah, anyway, but still we'll forget. Let us assume nothing happened.
सर
One second.
मतलब
Is there any
आना क्या
significance?
चाहिए था एक्चुअली?
Anyway, but I told to check and we got this. ठीक है तो.
So there is no significance for this.
Let us see. Right. So now if you do the same observation or experiment with the 3x3 matrix, shockingly you'll get the same answer. You'll still get the identity matrix. So what is the mechanism or science behind this? Let us see. So we'll start with theorems. Theorems of an adjoint matrix. First one. First theorem tells A into adjoint of A is equal to det A times I. This is first theorem. This is the first theorem. A into adjoint A is equal to det times of I. Okay. Proof. Proof is this is A into adjoint of A. So actually, adjoint of A is nothing but cofactor matrix of A transpose, right? So I'm just expanding this. Let us say this is some matrix A11, A12. I'm doing with the 3x3 matrix, okay? And the same will be true for n. See, instead of I can just write dot dot and n, but then you won't feel comfortable. I saw many students don't like it when you do that. So I'll do it with 3x3. And then you can logically understand that it is true for n. Now this is the wonderful part. Can you tell me what is the adjoint of A? Can you help me write adjoint A? बोले? Amisha Giri is not speaking today. Oh. What are the terms? Tell me quickly. What should come here?
C21.
Why C21? Why not C12?
So
So because we are taking transpose.
Transpose. Next.
C31.
Yeah.
C12.
Yeah. बोलिए बोलिए 3 2 1 3 2 3 3 3. Okay. Now multiply this. That is what we have to do. We have to multiply both of these. What are we getting on multiply? What is the first term?
A11 C11 plus A12 C12 plus A13 C13.
Does it have some nickname? No? No one? देखा देखा नहीं लग रहा किसी को. Does this seem familiar?
It's a point of destruction.
Definition.
Not destruction, definition, yes. Point of definition. Next one. A11 into C21. A12 into C22. A13 into C23. This becomes?
Zero.
Huh? Huh?
Zero.
0. Why?
Point of destruction.
Similarly, what is the next term? Okay, jaldi बोलिए, बाकी terms बोलिए. What's with the suspense? Tell me, na. Simple.
Zero.
Next. Go ahead, tell me.
सर जीरो फिर मतलब बॉन्ड है फिर जीरो जीरो मॉड है मतलब फिर आई गया मतलब मॉड है इनटू आई.
Mod मतलब यहाँ determinant, ठीक है?
Yeah.
So this becomes a scalar matrix. Hence proved. Okay? Clear? Is that okay?
Sir, can you go back to previous page?
मैं पूछा ना, is it okay? Is it okay?
एक second. Yes, sir.
अच्छा. Okay. Second point, right like this. Second point, don't say second point, call this a definition. Let's call this a definition first. What is the definition? If A is not a singular matrix and there exists a matrix, yeah, this is what I was telling today, and there exists a matrix B. There exists a matrix B such that there exists a matrix B such that AB equal to BA equal to I, then B is called as the inverse matrix of A. B is called as the inverse matrix of A, and is denoted by A. Is denoted by okay. So this is the definition of inverse matrix. What is inverse matrix? A matrix B such that A into B equal to B into A should be equal to I. Then we say that B is the inverse matrix of A. It's denoted by the symbol A inverse. Okay. Now you write the second theorem. Theorem 2. If det A does not equal to 0, then multiply by A inverse. Because from the definition, if this is not equal to 0, then A inverse exists. Then A inverse into A into adjoint of A will be equal to A inverse times of scalar, I mean this det A times of I. Is this step clear? I'm multiplying basically A inverse on both sides through theorem 1. You multiply A inverse on both sides in theorem 1. But A inverse into A will become I. So I times of adjoint A. And here I can take the scalar out as we showed in the first class. And I can write this as A inverse into I. So I into this is again adjoint of A. Det A times of A inverse into I will be, or in other words, A inverse is defined as 1 by det A times of adjoint of A. A inverse is defined as 1 by determinant of A times of adjoint. Okay. Now I think all of you understand why we got this. Clear? Can I go ahead? Thank you. Or let's just say 3. Theorem 3. What is the proof? By determinant of A. Okay, मतलब yeah. Okay. This is nothing but, can I say this is mod b times of mod a? Sorry, delta into delta b. And here adjoint of C. What is adjoint of C? C is nothing but A into B. What do you mean by adjoint of AB? Huh? What is the definition of adjoint of a matrix? Anyone? If you don't speak, it's very, very boring actually. What do you mean by adjoint of a matrix?
So transpose of
Transpose
cofactor
of the
matrix.
cofactor matrix.
Yeah. So can I say this is okay? Cofactor of AB matrix, whole transpose. Okay. Okay. So basically, the cofactor of matrix AB. After multiplying these two cofactor matrices, you're taking transpose. But we already know that basically this is the product of two matrices and you're taking transpose. Can I say that this is the same as cofactor matrix of B transpose in the cofactor matrix of A transpose? What is the reason? Because we know AB whole transpose is equal to B transpose A transpose. From here, can I say the same will happen with the cofactor matrix? So then I am splitting it in this way. So transpose of cofactor is nothing but adjoint. Yeah. Basically, this is B inverse.
But sir, it is always true that cofactor of CAB is equals to transpose of CB into transpose of CA.
Yeah. Is it always true if cofactor of AB matrix whole transpose? Cofactor of AB matrix for whole transpose.
अच्छा हाँ
समझ गया क्या?
हाँ
From here you can prove this also. Right. So these are theorems. Now, actually, it's very interesting. If you go into the proof of each and every one of them, quite interesting. Proofs are quite interesting. So how should we do it? Should I do the proofs myself, or do you guys want to try it? Not all, but at least one of them you can try. You want to try fourth one, or I should do it? What do you guys think?
Sir, give us some time.
Yeah, what we'll do, some things I will give you time at home. You do this as homework. The ones which I feel all of you can do by yourself, I'll give as homework and you do it. This you can try as homework. This you can try as homework. This you can try as homework. This also you can try as homework because I'll explain fifth one right now. Fifth you might find a little confusing. So I'm proving fifth one right now, okay? Is that fine, or else it will take time? And anyway, it is possible. It is not difficult. Go by the definition, you'll be able to prove the other ones. Is that okay?
Yes, sir.
So fifth one is a little confusing to many students, many students, and many questions are asked on this theme, right? So the fifth one is telling the determinant of the adjoint matrix is determinant of a power n minus 1. What is n here? Any guesses?
Sir, the order.
Yeah, very good. N is the order of a. So how do we prove this? We actually prove this by theorem 1. What does theorem 1 say? Can anyone tell me without looking at your books? Okay, at least with looking.
The A is equals to determinant of A into I.
अच्छा, you're telling दोनों साइड डिटरमिनेंट है ना? हाँ, दोनों साइड डिटरमिनेंट लेने के लिए बोल रहे हैं ना? What will this become? Can anyone tell me? अगर ये बोल पाएंगे तो सब कुछ समझ गए आप लोग. ये एक पॉइंट अगर बोल पाएंगे, what will this become? Finish. That means half confusion is finished.
Sir, is it A?
No. So your confusion is not finished. Others? See, I told on the first day of matrices, there's a difference between matrix Ka and there's a difference between determinant Ka. I'm sorry, in the sense, there's a difference between matrix K and the difference between K times of determinant. Very important difference between these two. In other words, this does not equal to determinant of Ka. Everyone is aware of that. Whose order should be greater than. Think about it. It might be difficult also because if you don't know the properties of determinants, then you might not be able to answer. I'll do it because not all of you are aware of determinant properties. Actually, what is this? Determinant of A into In is nothing but determinant of A is 0, 0. For example, I'm taking a 3 by 3 matrix. Okay. So something which many of you might not be knowing. In a determinant, actually, you can take out an element common from each row or each column. Are you guys aware of this property?
No, sir.
Sir.
Actually, I'm taking a determinant A common from the first row. Can you tell me what is the next row? Please tell me. Huh?
Sir, 1, 0.
No. That is the whole point.
And of A.
See, in determinant, you cannot take an element out of the entire matrix. You can only take it out of one column or one row at a time. Now, if you want to take this out, you have to take it out again separately. Now you can write this as 0, 0, 0, 1, 0, 0, 0, det A. And if you want to take that also out, basically what are you doing? You're taking it common out of each row. Then it becomes cube. 1, 0, 0, 0, 1, 0, and 0, 0, 1. Which is nothing but A determinant of A cube times of I. Keeping this in mind, can you guys tell me what is the determinant of this? Anyone?
So is it 1 by det A 0, 0, 0, 1, 0, and 0, 0, 1?
No, I don't understand how you said that. Just take det A common from every row. How many determinant A will you take out common? As many rows are there? है ना? Or as many columns, whatever. Anyone are you guys understanding or not? No one is understanding. So this is a property of determinant which I am not taught, but that is how you take things out common in a determinant. You can only take it out from one row at a time. You cannot take it out entirely. In a matrix, you can take it out, but in a determinant, you cannot. And this I explained that day. When I taught matrix that day itself, I told that be careful with the point, because in determinant, the same property is not true. In determinant, you can take it out of an individual row or individual column. Okay. Why that is so, I'll explain later when I explain the properties of determinants. But till then, can you try to use this logic and tell me what will be the RHS? Amisha Giri? Determinant of A? Yes? Okay. Anyone else?
Sir, to the power n.
Okay. Why did you say that?
Sir, because over here we have I of order n.
So we have n rows or n columns. Good.
Yes.
Did the other students understand this? Other students, Mayuk, Vaishnavi, Avingshu, Riya?
Yes, sir.
No, sir.
See, whatever I did here, same logic. Here I took determinant of A common from the first row. Did you understand, Vaishnavi?
Yes, sir.
Then I took it out from second row and it became square. Then I took it out from third row, it became cube.
Yes, sir.
Now if it is of nth order, then I'll do the same process in n rows.
Yes.
That is what she did. Okay. So after you take it out of n rows, it becomes determinant of A power n into I. And then determinant of I is 1 anyway. So this is the only thing which will remain. Okay. So remember this. So then determinant of adjoint of A. Therefore, you can cancel out one A. This will become n minus 1. This is nothing but determinant of A power n minus 1. Okay. Clear?
Yes, sir.
Good. Okay, I'll take 2 minutes. I'll give 2 minutes, and I want all of you to try theorem 8. If you understood this theorem, do this right now. I'm giving a hint.
Sir, how you are cancelling out A on both sides? I don't.
Because here determinant is कुछ number है ना, तो कुछ क्या दिक्कत
अच्छा
है?
अच्छा अच्छा हाँ हाँ ठीक.
Try this 8th theorem right now. Right now, I want all of you to try 8th theorem. Let adjoint of A is equal to B. This is a clue, and you try to prove this. कीजिए अभी कीजिए, सब try कीजिए. See, if I give a question for homework, do you guys do it at home or not? Does anyone do the homework I give? You should do. All of you are grown up, so I don't push you much. I don't push you guys like I push 9th class, 10th class. Should be serious. That day I told all of you to complete that JE advanced question. Did you try that? A, B, C, A symmetric, B, C are skew symmetric. Did anyone try after going home? Not
Yes,
going
sir.
home. After class. What? Did you get the answer?
Yes, sir. I got the last two options.
I think it's not the right answer. Anyway, fine. The point is, whatever questions you are given, you can check actually. It's a question from 2015. Some of you might think, sir, what is a big deal? You tell us to try one question at home. We don't do it for what? It is a big deal. Trust me. Because these small things make a big difference. I've seen. In JEE exam also, there is not actually a big difference between students. Many students prepare everything and go, but the way they prepare, the commitment, how much they have practiced, all that makes a difference. Attitude makes a lot. Did anyone get it? We have to prove that adjoint of adjoint A. Okay, did anyone do anything or should I go ahead? Okay. So this is the
Sir,
tricky part.
can you wait for 1 minute? I think I got.
Okay. आया अभिषेक?
नहीं आ रहा, sorry.
Okay. No, good, very good. I'm happy you're trying. So here A into IN becomes A, and here A into this becomes inverse A. So directly I'm writing data into adjoint of it is equal to determinant of adjoint A. What is determinant of adjoint A? This we proved in the last class, last theorem. Determinant of adjoint A is det A whole to the power n minus 1. So this I am cancelled for n minus 2. Therefore adjoint of adjoint will be determinant of a whole floor n minus time, no? Okay. So then my next question is, what is the determinant of adjoint of adjoint? Did everyone understand this proof? Any doubt in any of the steps?
सर मैंने जो किया वो थोड़ा आप देख सकते हैं,
दिखा?
मतलब मैं कैमरा ऑन कर।
हाँ हाँ sure. One second. You share the screen. हाँ right. नहीं ठीक है. Zoom कीजिए. Adjoint of A का inverse. अच्छा adjoint A inverse जैसे लिख दिया. कहाँ स्टार्ट हो गया? Adjoint of A inverse into adjoint A is equal to det A inverse. So this is like that theorem, na? A inverse into A is equal to det A times in. उस स्टेप से लिखे क्या आप? फर्स्ट स्टेप कैसे लिखा अभिंशु? म्यूट
सर पहले मतलब एडजॉइंट ए इक्वल्स टू मतलब हम लिख सकते हैं डिटरमिनेंट ऑफ ए इनटू ए इनवर्स।
adjoint of A is determinant A into A inverse.
मतलब वो जो फर्स्ट थ्योरम था।
हाँ ठीक है।
फिर बोथ साइड मैंने एडजॉइंट ए होल इनवर्स लिया, देन एलएचएस आपका आइडेंटिटी मैट्रिक्स हो गया। और
एक थोड़ा गड़बड़ किया है इस स्टेप में, अनफॉर्चुनेटली फर्स्ट स्टेप है, लेकिन आप ऐसे मल्टीप्लिकेशन नहीं करना चाहिए ना। मल्टीप्लिकेशन इधर दोनों राइट साइड चेन है और दोनों लेफ्ट साइड करना चाहिए, है ना?
अच्छा हाँ।
एक राइट एक लेफ्ट तो करना गलती है ना?
हाँ
ओके एक सेकंड, ये आई कहाँ से आया?
सर वो जो एडजॉइंट ए इनवर्स फिर एडजॉइंट ए,
ओके ओके हाँ इज इक्वल
फिर
टू
सर
आई
वो आई हो जाएगा।
ओके ओटा ভালো and that A into A inverse into adjoint of A inverse into A inverse। अच्छा फिर दोनों साइड
एक्चुअली मैंने
एक सेकंड दोनों साइड A मल्टीप्लाई कर रहे हैं तो फिर ये हो गया, तो I A is equal to det A into det A का इनवर्स is equal to A by det A। अरे आप actually you should go into research। I'm very serious Avingshu।
सर एक्चुअली गलती हुआ है, मतलब ये आगे पीछे लिख दिया मैं टर्म्स।
हाँ ठीक है बस ये गलती थोड़ा कम कीजिए, नहीं तो बहुत अच्छा है, यू थिंक वेरी डिफरेंट। हाँ, लेकिन आगे पीछे तो लिख दिया आप। बट इफ यू बिकम साइंटिस्ट ना कुछ
हाँ।
निकल जाएगा आपका रिसर्च से। ओके, एडजॉइंट ऑफ ए इनवर्स इज इक्वल टू, अच्छा ठीक है, अच्छा है, पावर एन माइनस पावर एन। आई थिंक इट्स फाइन मे बी। एक गलती किया फर्स्ट स्टेप में, कुछ गलती किया, बट नाइस, गुड, you deserve Nobel Prize, but Sarthi Nobel Prize. Good, very good, Avinshu. We from the core of our hearts appreciate Avinshu for his what do you say? For his intuitivity and innate geniusness, for his extreme effort in trying to prove this theorem. ठीक है. Now stop your screen share. Yeah, thank you. Nice, very nice. Yeah, let's come back to the boring whiteboard. Unfortunately, you're back here. Yes.
सर ये आपने कैंसिल कैसे किया, एक बार फिर से बोलेंगे? दिस स्टेप, दिस सेकंड लास्ट स्टेप।
या कैंसिल नहीं किया, डिटरमिनेंट ऑफ एडजॉइंट ए पिछले थ्योरम था ना, डिटरमिनेंट ऑफ एडजॉइंट इज det a power n minus 1. I cancelled determinant of a and determinant of a power n minus 1 and wrote determinant of a power n minus 2.
ओके ओके ओके, फाइन।
Like x power n minus 1 by x is equal to x power n minus 2, like that.
ओके सर।
Okay. Yeah, next question. Try this next. Try this. Anyone get the answer? No one got it, huh? Are you people trying this or you're doing something else? Huh? Avinshu, Riya, Vaishnavi?
So trying.
Sir,
Hmm.
a to the power n minus 1 whole square.
A to the power?
Determinant of a to the power n minus 1 whole square.
Wow, wonderful. Very good. Okay. Good. कैसे बताओ?
Sir, if we take adjacent of adjacent a, then it will come mod of adjacent a to the power n minus 1. Then again, if we take adjacent, then it will be mod of a determinant of a to the power n minus 1 whole square.
Adjoint है पहले बात, adjacent है. But कैसे धीरे धीरे बोलो कैसे क्या?
सर इधर एडजॉइंट ऑफ एडजॉइंट ए है, तो इसको जो हम थ्योरम प्रूफ किया उसके मतलब उसके बेसिस पे हम लिख सकते हैं कि डिटर्मिनेंट ऑफ एडजॉइंट ए टू द पावर n माइनस 1. फिर अगेन हम अगर एडजॉइंट मतलब वो थ्योरम फिर से यूज करेंगे तो डिटर्मिनेंट ऑफ ए टू द पावर n माइनस 1 टू द पावर n माइनस 1 हो जाएगा. फिर
वेरी गुड. यही बोले ना.
हाँ.
But deter भी is nothing but adjoint. है ना?
Yes sir.
वाह, brilliant. Very good. So wonderful. Na? Nature is so wonderful. All of you are, some of you understand something, some of you understand some other thing. Some of you understood the former part so nicely and you're confused here. And some of you are doing this part so nicely, but you're confused with simple things. This is the beauty of creation. We can appreciate nature by the way Avinshu is answering questions.
Sure.
How he is not doing so many simple questions, but he is doing all these questions.
Sir,
Yes.
sir,
Yes,
can
we
you
can
give
appreciate
some?
the nature through your doubts also. You're not understanding, na, adjoint there.
No, sir. Can you give some physical representation or any way?
There's no
I'm not
physical
able to.
representation. Yeah, maths in this chapter at least, there's no physical representation. But see, what we mean by adjoint of adjoint is, it is not something you can appreciate physically as such. It is all mathematical manipulation. Because when you're saying adjoint of an adjoint matrix, you're taking adjoint of a matrix whose cofactors are defined. It is a cofactor matrix, no? So on taking the adjoint of this cofactor matrix, it is not necessary that you're going to simplify the question further. So adjoint of adjoint matrix. We proved that adjoint of adjoint. Where is that? Yeah, determinant of a power n minus 1. You can think of it this way, maybe it is possible, but the simplest way to understand this is through the previous properties. The adjoint of adjoint, simplest way would be to understand through this. And if you want to serve the purpose for the exam, better you learn it in this way. But I'm not telling this is the best way. But from exam point of view, this approach is good. If you're finding this is difficult, go back to the theorem 1. And from theorem 1, try to understand theorem 2. And from theorem 2, you try to prove theorem 3. And then you try to prove the other theorems. That is better. Now, what you are saying is also very good. In the sense, you want to get a better understanding of what is adjoint of adjoint. How it is actually becoming determinant of a n minus 2 into a. You want to understand this, no?
Yes, sir.
Yeah. So you can sit down and you can try it. And you might get it. But it's not worth the time. Because you can spend so much time trying it, or you can try to search for it also, but it simply is not worth the time. If you are really focused JEE point of view, but if you want to really go deeper into the subject, then I recommend you can try. At least I have not tried to think of it in this way, from the fundamental definition. I have always taught it in this way. I prove one property from the previous property from the previous property. See, it's like I defined adjoint, and then I define something. I define cofactor, then adjoint, then something, then something, then something, something. And there I proved this adjoint of adjoint. But now if you want to understand this thing with respect to this, then it will take some time. It's possible, but I have not done it, and I don't recommend you do it unless you want to spend time there. Okay. If you're serious about understanding this, better you can understand from the properties, from the previous properties you try to understand. That is better, and that will be more satisfying also. You try to prove the theorems in the same sequence by yourself. Don't look at it and try to prove them yourself. That is much simpler. Okay.
Okay, sir.
And the same things you can do in multiple ways. Like I'm also seeing right now, no? The way I was going to prove it is different actually, but Avingshi is proving it in different ways. I had a different thing in mind in book also. When I did it in this way. I wrote that adjoint of adjoint A would be, I just took a determinant on both sides over here, but see, he did not do it. He used the previous definition. Very nice. What he did is also very, very nice. But I did it this way. Since we proved this, that is how I like to work. Using that result, I am writing determinant of a power n minus 2 times of a. Now, if you assume that this is some k times of a, then again, as I told, this becomes k power n times of delta. This is what I explained the last time. Because k, when you're multiplying with a matrix, it spreads over every element. But then when you want to bring it outside the determinant, you have to bring it out from each row or each column. So this becomes k power n. But what is k? K is nothing but determinant of a power n minus 2. So n into n minus 2 becomes n into n minus 2, n square minus 2n. But here also you have delta, so plus 1, which is delta to the power n minus 1. So if you go one step back and you prove it from this theorem, you can understand it this way. If you go 2 steps back and you use this theorem, still very nice. If you want to go 10 steps back, maybe you'll get something nice. So you can try out yourself. But again, you have to think if it's worth the time or not, because you have limited time. And I'm going to teach many things. So you should think whether it's worth the time or not. Yeah, you can copy this method also. Okay. Okay.
Okay, sir.
So these are the various properties of adjoint. Apart from that, I have some important properties in inverse function also. One second.
Sir, can you go to the previous page?
सर
बोलिए.
सर यहाँ मतलब वो जो एडजेसेंट ऑफ एडजेसेंट ए वाला प्रूफ में एकदम सेकंड लास्ट स्टेप में आप मतलब आप जो किए है उसमें एडजेसेंट ऑफ एडजेसेंट ए मतलब डिटर्मिनेंट ऑफ ए मल्टीप्लाइड बाय एडजेसेंट ऑफ एडजेसेंट ए इक्वल्स टू एडजेसेंट ए इनटू ए टू द पावर डिटर्मिनेंट ऑफ ए टू द पावर n माइनस 2 लिए है मतलब आया है उधर.
नहीं वो वैसे नहीं है. ओके. अब ये चीज और ये चीज कैंसिल कर. सॉरी n-1 था.
हाँ फिर n माइनस 2
n-1 था ना.
हाँ
ठीक है. ओके.
ओके.
How many theorem did you do? Theorem 8. Theorem 9. Determinant of A inverse is actually 1 by delta. Can anyone prove this? The inverse matrix determinant, if you find it, is actually 1 by delta. What is the proof? This is nothing but 1 by delta times of adjoint of A, which is equal to 1 by delta whole power n into delta of adjoint of A, which is 1 by delta power n into this is delta power n minus 1, which is equal to delta power minus 1. See here, this minus 1 is not same as this minus 1. Don't be confused. The minus 1 over here and minus 1 over here are both different. Okay. This is what the -1 over here means. Okay. Important theorem. Looks quite simple or something, but it's important. Next theorem है k times of a whole inverse is equal to 1 by k times of a inverse. Very interesting. Na? If you are multiplying a scalar k with a matrix, then if you take the same k out of the entire inverse, it actually becomes 1 by k.
Sir, can't we tell it K inverse?
See, that's what. Be very careful. This inverse does not mean 1 by ka. इस इनवर्स का मीनिंग अलग है ना. दिस इज मैट्रिक्स इनवर्स. सो उसको बाहर जब लाते हैं, it doesn't mean anything ना. How can you take matrix inverse of a scalar? ठीक है. What is the proof? What is Ka into K inverse? What is A into A inverse?
I.
Good. From here, first and foremost, I am taking K to the other side. Because it is a scalar, I am writing it this way. 1 by K times of I. Next, I am multiplying with A inverse on both sides. So then this becomes, the inverse is outside, okay, be careful. Okay, fine. Theorem 11. Adjoint of A power K is equal to adjoint of A whole power K. How do you prove this? Proof. Adjoint of A power K is equal to adjoint of A into K times, which is actually adjoint of A into adjoint of A into adjoint of A K times. So this property will be confused. Actually, previously we have proved here as adjoint of AB. Adjoint of AB is adjoint B into adjoint A. Yeah, remember, if you use the same property, you can prove this. Then this becomes the adjoint of A whole power K. This becomes the adjoint of A whole power K. Hence proof. So from this, you can also prove the next. theorem. Whole power k becomes a power k whole inverse. How? What is the proof? Proof is use the above thing. Proof क्या होगा? A inverse whole power k is nothing but 1 by det A adjoint of A whole power k, which is equal to 1 by det is anyway a constant. So take it out. So adjoint of a whole power k is same as adjoint of a power k, and here also you write this as 1 by det of a power k, because you can bring this constant out of C. This property is there in determinant. Determinant of a square is same as determinant of a into determinant of a. So here I am taking the k inside, hence proved. This has become, which is same as this. Okay. Okay, I have more, but I'll stop here. Stop here because other theorems are just like namesake theorems. See, all of them actually, in one sense, first few theorems are important. Other things you can just derive as a consequence. So I personally feel these many theorems I can spoon feed, and if further questions come, then it's up to all of you to tap your brains and see how to get it. Okay, but these are the basic theorems. Not basic actually. This is actually an extensive elaboration, but still, this much I feel should help you sail smoothly. Any doubts so far?
So can you mail these notes?
Yeah, sure, why not? But you're copying also, no?
Yes, sir.
Okay, no, I'll make. So, special type of matrices. So this week's syllabus will be special type of matrices. Transpose, adjoint, inverse matrix, rank of matrix, solution of equations using matrices. Okay, I think we covered more or less everything. We'll do rank right now, and solutions part we'll do on Saturday. I think solution part is important for your board exam. Finding solution using inverse matrix. It is a very big, elaborate, and slightly boring process. I'll also have to refer before I teach. I'll check NCRT, what is there in NCRT, and teach accordingly. Right. Fine. So we'll go to the next topic. The rank of a matrix. Small topic, 2 minutes, few minutes, and then we'll stop. Okay. Does anyone remember what we mean by submatrix? Did we define submatrix? Huh? Did we define submatrix?
Yes,
Yes.
sir.
What? What
So
do you
it is matrix obtained by eliminating any number of rows and any number of columns.
The matrix obtained by deleting some rows or columns or both. It's called submatrix. So definition. Now we're going to the definition of rank. Let A be a non-zero. Let A be a non-zero matrix. Let A be a non-zero matrix. The rank of A. The rank of A is defined. The rank of A is defined as the maximum. Defined as the maximum of the order of the non-singular square submatrix. Square submatrices of A. The rank of a null matrix is defined as 0. So the symbol, what is the symbol? Symbol is rank of A. This is the symbol. Okay. So from here I can write. If A is a non-zero matrix. If A is a non-zero matrix of order 3, then its rank is 1. If every 2 by 2 submatrix is singular. 2 if A is singular. If A is singular and at least one of its 2 by 2 submatrix. 2 by 2 submatrices is non-zero. Three if A is non-zero. Okay. Write this down. I'll give an example. Tell me when all of you are done.
सर आप थोड़ा रुक जाइए. डन सर. आप
सबका हो गया?
Yes, sir.
Yes, sir.
Example. Okay, I'll write a matrix. You tell me its rank. A1 is equal to matrix 1 2 1 minus 1 0 2 0 1 minus 1. Find its rank. Oh, I think all of you didn't understand. What are you guys doing? Hmm? Waiting for me to answer. Okay. Can someone tell what are we supposed to do by reading all this? No?
Determinant of A.
Very good. Yeah. First step is you have to find the determinant. What is the determinant of A1? -5 आना चाहिए.
-5.
So from that you can tell it is a third point. So if a 3 by 3 matrix is non-single, then its rank is 3. Hence rank equal to 3. Right. Next, second example. This is A2. या इसका डिटरमिनेंट क्या है?
0.
So then its rank cannot be 3. So what is the next step? Next step is you have to check the next submatrices which are square. So if the order 3 matrix is not having a rank 3, matlab if its determinant is 0, then now you have to check 2 by 2 matrices. So you can select any 2 by 2
So
matrix.
2 by 2 matrix is means not 0.
Not 0, bus implies rank is 2. मतलब you stop at that point when you find the determinant is not 0. मान लीजिए 1 इसका determinant अगर 0 हो गया, then you check for other 2 by 2 matrix. If this is not 0, बस खत्म. Then rank is 2. But if all the 2 by 2 matrices determinant is 0, then you go to 1 by 1 matrix.
Sir, what is the utility of rank of matrix?
I'll tell him, but do you understood rank, na?
Sir, one
Yeah.
second. I have a doubt.
Yes.
If we tell that each, like if I take every 2 by 2 matrix and then I find out that the determinant is 0. So, like if I have a really big matrix, then what am I supposed to do? I can't go on finding out 2 by 2 matrix or determinant.
Yeah. Whatever big matrix, you have to start from the biggest order. If you have 10 by 10, then start checking by 10 by 10. If you have 10 by 5 matrix, what will you do? You have to start checking every 5 by 5 matrix. You have to check every 5 by 5 matrix and see if they're singular or non-singular. If all of them are singular, then next you have to check every 4 by 4 matrix. If all of them are also singular, go to 3 by 3. Okay. Is your doubt clear?
So sort of.
What part is not clear?
So isn't there any shorter method to do this? It will take a long time finding out.
In exam, they won't ask you to find all that. Na? In exam, they'll give 3 by 3 at max.
Okay.
Okay. So anyway, you have to find determinants. So you have to find determinant of this simple. If it is not this, then you go to 2 by 2 will not take much time to find. 2 by 2 maths you can solve quickly. That way it is fine. Okay. This is okay?
Yes, sir.
So,
I have some method here, but I don't think this is part of these. Okay, we'll end today's class here. Okay. Thank you very much.
Thank you, sir.
thank you, sir.
Thank you, sir.
Yeah. I'll mail the notes to Vaishnavi as asked. Okay.
Okay, sir.
And I'll mail to Avingsha also. If required, you can post them.
Okay, sir.